Hello everyone and good day and welcome to my YouTube channel. In this video lesson, we are going to appreciate the proofs of the alternate segment theorem. So we'll be constructing the GeoGebra visualizations and illustrations for these proofs, and then we'll enjoy the narrative of any algebra used for such proofs, and we are going to have a look at any available GeoGebra builds visualizing these proofs. So let's start with case number 1. In the first case, the chord passes through the center. So let's begin. So are the elements of our proof. So first circle, and then we are going to create a chord that would pass through the center. So it means the chord is the diameter. Then the next element that we're going to create is of course the tangent line. So call the functionality tangents and then click on a point and the circle. So we now have the tangent line. And then recall, what is the relationship of the line that passes through the point of contact? Recall the point, okay, where the tangent line touches the circle as point of contact. So what is the relationship of the line that passes through the point of contact and the tangent line? You are correct. The line that passes through the point of contact is perpendicular to the tangent line. So here's the point D here. And then here's the visual proof. Again, perpendicular lines form a right angle. So we have here the right angle. Okay, and a very important theorem or property that we are going to use for this case, right, is the property wherein the angles in a semicircle is 90 degrees. So the next element that we are going to create is of course the angle at the alternate segment. Okay, so again, this 90-degree angle here is already the angle formed between the chord and the tangent line. So we are now going to create an angle at the alternate segment. To do that, we are going to have a point at the alternate segment. Okay, and then we are going to connect that point at the alternate segment to the endpoints of the chord. So E will be connected to F, and then E will be connected to C. So what do we have now? Yes, we have an angle formed in a semicircle. So this is the semicircle, right? Okay, so the property of any angle in a semicircle is this. Angles in a semicircle is 90 degrees. Alright, so here's the visual proof. So the angle of FEC is 90 degrees. Again, angles, the very useful property, angles in a semicircle is 90 degrees. Okay, so again, if we're going to move the point along that semicircle, okay, the angle will always be 90 degrees because any angle formed in a semicircle is 90 degrees. So the proof is straightforward. If we have a chord that passes through the diameter, then the angle at the alternate segment, okay, is an angle of a semicircle. So that would be 90 degrees. And the angle formed between the chord, okay, AC, and the tangent line CD is also 90 degrees because any line that passes through the point of contact is perpendicular to the tangent line. Okay, so thank you for staying. So let's appreciate the build of To, We, Pek for this first case. So again, we have the tangent line PAQ, or I mean tangent line PQ, and then the chord is BA, right? And with this construction, we are going to have a semicircle. So the alternate segment formed is a semicircle. And then, okay, we all know that the line that touches the point of contact is perpendicular to the tangent line. So, what is the point of contact again? It is the point where the tangent line touches the circle. So, if we are going to have a line that passes through the point of contact, that line will be perpendicular to the tangent line. And we all know that a tangent line form or perpendicular lines form a right angle. Okay, so we have here angle OAQ is 90 degrees because the tangent line is always perpendicular to the radius, okay, or to the line that passes through the point of contact. Okay, and now we are going to create the angle at the alternate segment. Right, so since the chord passes through the center, or it's the diameter, then the angle formed at the alternate segment will be an angle formed in a semicircle. And there is again a property that all angles formed in a semicircle is equal to 90 degrees. Hence, we can say that angle ACB is indeed equal to angle BAQ. Hence, we just proven the narrative of the alternate segment theorem, which states that the angle formed between the chord AB and the tangent line PQ is equal to the angle at the alternate segment. Alright, so thank you so much for watching until the end. And then please stay tuned because we're going to have another video for the second case. Alright, so our second case is to have, for the second case, we're going to have angles at the same arc, or it's a construction wherein the angle and the chord are not at the same semicircle. Alright, so thank you so much for watching again until the end. Bye for now.